Hello everyone, let's go through the now you try problems for looking at equations in x and y and determining if x is a function of y or y is a function of x. That is, if we think of x as the inputs and y as the outputs, would that be considered a function? And if we switch it around and think of y as the inputs and x as the outputs, might we be able to think of that as a function? So let's jump in to part A here, where we have x squared plus y squared equals 9. And let's just think if x equals 1 as an input, is that what I really want to choose? So let's just choose x as 0. It'll be easier. Then we'll have y squared equals 9. And then if I take the square root, I get that y equals plus or minus 3. So 2 outputs. So we can say y of x is not a function. If I plug in an x value, we get more than one y value potentially. If we switch it around, if y equals 0, then we get x squared equals 9 and x equals plus or minus 3. So x of y is not a function either. In fact, x squared plus y squared equals 9 is the graph of a circle with a radius of 3. And so if you look at it sideways or up and down, you're going to have, for a single x value, you'll have a point above and below. If you have a single y value, you'll have a point to the left and to the right. So we'll see that that's not a function in either direction there. A circle is a perfectly good object. This equation is perfectly good. We just wouldn't consider it a function no matter which way we looked at it. The next equation we have is x equals y cubed. Given any y value, if we plug that in, cubing only results in a single output. So x of y, x is a function of y. X of y is a function. And if I solve for y in this, I'd get y equals the cube root of x. And so since cube rooting only gives one value, y of x is also a function. So that one's not too bad. Let's look over at part C. This one's going to be a bit more complicated. If I plug in any x value, well, there's only going to be one y output, but let's make sure we understand why. We would plug it into the top and to the bottom. X plus 2 has one value. 4 minus x has one value. And then dividing those has one value. So y of x is a function. Given an x value input, we only get one y value output. All right, let's try the other way. If we're given a y value, let's say, let's think of a good one. If y is 1, for just an example, we're not going to be able to really prove this conclusively with what we have right now, but we'll get at least our heads wrapped around it, hopefully. If y equals 1, then I need the top and the bottom to both be 1. The top and bottom need to be the same. So we'd need x plus 2 to equal 4 minus x, right, for y to equal 1, so that the division on the right side would have just a single number. Now I can add the x to the left and get 2x, subtract the 2 to the right to get a 2, and then x just equals 1. And we could choose this for any y value, not just y equals 1. This works for any y value. You can try a few if you'd like. So x of y is a function. If we choose a y value as an input, there's only one x value as an output that corresponds. All right, we've got 3 more here. X equals y squared. Given any y value, we're doing this one first just because I have y squared. Squaring, or y squared equals x, squaring only gives one x value. So x of y is a function. On the other hand, if x equals 1, then y could equal plus or minus 1, right? We could square plus or minus 1 to get an x value of 1. So y is not a function of x. That is, y of x is not a function. Given an x value, we could get more than one y value out. Now for part E, we'll start with y of x is a function. And that's because our order of operations say we'd square the number, we'll only get one number out of that, and we'll go 36 minus that, and we'll only get one number, and then we take the square root, and we'll only get one number. If x is big enough, then we could get no answers, but that's okay. That would just be x values that are not in the domain. We can say y of x is a function by the order of operations. Now if we try and go the other way, I'll rewrite this and we'll solve for x as best we can here, 36 minus x squared. Let's try plugging in a y value, right? If I plug in a y value, can I get more than one x value potentially? Let's say if y equals 0, we'll get 0 equals the square root of 36 minus x squared. I'll square both sides to get 0 equals 36 minus x squared. I'll add the x squared to the other side to get x squared equals 36. And then we can see that x could equal plus or minus 6. So for a given y value, we could get two x values out. So x of y is not a function. All right, we got one more here to finish up this video. For the last one, we have y equals the 8th root of x. So if I take an 8th root, that's like a square root, but it's saying what number times itself 8 times will give us the input to that 8th root. So and that's always going to give us the same answer. There's only going to be one answer to that. So for any x value, we only get a single y value. Since an 8th root only has one answer. So we can say that y of x is a function. On the other hand, if I say let y equal 1, then x equals 1 is the only way to get 1 out. Let's try and generalize that a little bit. But if I take the original equation y equals the 8th root of x, and I take and move that 8th root to the other side, I get y to the 8th equals x. And then given any y value, an 8th power only has one output, so x of y is a function. All right. So that gets us all the answers to these. I'm going to give you a little bit of a little bit more confidence with this. This is really just an exploration to try and get you used to the idea of what is a function. If you're not fully grasping how to approach all of these different examples, that's okay. I'm not expecting you to. But hopefully by going through these, it starts to give you a few more connections on how functions work. Don't stress about having this all figured out right away on the first time that you've gone through this. We'll talk about it more in class a bit, and this isn't really the kind of thing that I want to test on so much. This is more just an exploration for concept building while we go through the learning process. So I hope that this at least helped a little bit with making some more sense out of what is a function. And then as the term goes on and we dive into specific kinds of functions, then we can talk about if we look at them the opposite direction, will that still be a function? And in Math 111, you'll explore that a lot more. So this is really an introduction. All right. Well, thank you so much for watching, everyone, and we will see you in the next video. Take care.